Good evening, everyone. Good evening. I'd like to thank you for coming here tonight to join us for an evening with Phil Plait and his presentation, Eclipse Across America. I'd like to thank a few people that have been involved in helping get this project up and running. Theater director Joey Cole and Mark Christ, head of the adult programming here at CALS. Nathan James, and a few others. I'd like to thank all the staff here at the Ron Robb for helping bring this about. My name is Daryl Heath, and I'm with the Arkansas Space Grant Consortium. And if you're not familiar with the Arkansas Space Grant Consortium, we are a NASA-funded agency. It began back in 1989. If you go to the NASA website, you'll read a description that says something like, we're a national network of colleges and universities working together to expand opportunities for Americans to understand and participate in NASA's aeronautics and space projects by supporting and enhancing science and engineering, education, research, and public outreach efforts, all of which is true. But I need to give you a bit of context there and give you some ideas as to exactly what we're doing. For example, for the outreach part, did you know that if you are a card carrying member of CALS, that you can check out telescopes just like you can a book? That's thanks to the ASGC and the Central Arkansas Astronomical Society. We've partnered with them to bring telescopes to the people of Little Rock and the Central Arkansas area. So yeah, you can check out a telescope and explore the universe from your backyard with just a library card. We have funded student research all around the state. We have students at ULR, for example, who are studying the effects of deep space radiation and microgravity on living tissue. We've got students at UCA who are working on soft robotics. They are developing robots using soft materials so that they move and bend like living organisms. And we can use these robots maybe in the future to explore other worlds. We've got a robotic telescope that we have funded at the River Ridge Observatory, which belongs to the Central Arkansas Astronomical Society. And our network of affiliates and college campuses around the state, their students and high school students will be able to monitor the transit of exoplanets across their parent stars. So we fund all kinds of research. And this is NASA's long-term investment to recruit people in the future to work for NASA to help us explore strange new worlds. And a lot of those people will be recruited from out of Arkansas, thanks to our efforts. Another thing that we're doing is doing programs like this. And without further ado, well, there's one other little announcement I want to make. This coming weekend, the Central Arkansas Astronomical Society is going to be conducting a star party at Woolly Hollow State Park. How many of you are familiar with Central Arkansas Astronomical Society through our star parties? Raise your hand. Okay, well, we do star parties from March until November. And the last one of the year is at Woolly Hollow State Park. That'll begin at 6 p.m. Correct me if I'm wrong. Jim, do you know? 6 p.m., Woolly Hollow State Park. And if you're not familiar with what a star party is, it's essentially where we astronomers come out, set up our telescopes, and invite you, the public, to come out and look through them. So you can explore the universe from Woolly Hollow State Park, and we invite you to come out. It's free, family friendly, so please join us. Okay. Without further ado, I am going to bring out Phil Plait. Phil, I have left your bio back in the green room. But anyway, Phil Plait is a longtime science communicator who has done his Bad Astronomy blog in various locations. Are you familiar with his Bad Astronomy books or blog? Okay. He started out by debunking various myths and misconceptions about astronomy, and he's become very popular over the years. He's done work with the Discovery Channel and how the universe works. He's done Crash Course Astronomy for PBS. He's even worked for NASA on the Hubble Space Telescope. He's done all sorts of things. So without further ado, I'm going to bring out Phil Plait. Help me give him a warm welcome as he returns to the Ron Robinson stage.
Thank you. Thank you, Daryl. And thank you, everybody, for coming and braving the weather. That looks good. I'm coming from Colorado, and I'm used to this. And I was just saying that when I always check the weather before I travel because I want to know what to bring. And I thought I'd forgotten to change my location. It's like, oh, wow, all right, cold and cruddy. All right, perfect. And I'm used to coming here for the governor's school, which is in June. And this weather is quite different than Arkansas in June, it turns out. So that's interesting. It's a pleasure to be here again. I was here a few years ago to talk about exoplanets, and it's great to be here again to talk about this eclipse. And I'm jealous of y'all because where I live, I'm too far from it. I'm not going to get anywhere near a good eclipse, so I'm going to have to travel. And you have to basically just blow a hole in this roof and you'll see it. What was that? Sorry?
We have a spare bedroom.
Oh, okay. Well, it'll just be me and 100 of my closest friends. How many of you have seen a total solar eclipse before? Oh, quite a few. Excellent. Good for you. Up until 2017, I had never seen one. Professional astronomer my whole life. I've seen pretty much one of everything you can see in the sky at some point, and had never seen a total solar eclipse until the one that passed over the United States in 2017. And I'm going to talk about the mechanics of it here, and how you can, why we get these things, why they don't happen all the time, why they're relatively rare, and also how you can watch it safely. But there's a lot more to it than that. Astronomy can be kind of a bloodless thing to think about sometimes, thinking about, well, let's talk about planets, and you don't really, there's not necessarily a real visceral connection. But when it comes to a total solar eclipse, it turns out it's a very emotional event. It's really, really terrific, and I hope you all get a chance to see this one, because to be able to see one at all is fantastic. To be able to walk out into your front yard and see it, and hopefully the weather will be good here. So let's talk about that. Total solar eclipse. Oh wait, how many of you saw the lunar eclipse 2 weeks ago or a week ago? Very few, and you know why? Oh, you said it was cloudy, right? Yeah, besides it being cloudy. It was also at like 4 in the morning, and screw that, right? It was super, super late for me in Colorado, and I was like, yeah, and it's going to be cold and probably cloudy, so I didn't look. But those are fun. And a lot of people have seen them because they are long events. A lunar eclipse will last for over an hour. And so it's not hard the entire event takes actually several hours, but the deepest part of totality, when the moon is blocked by Earth's shadow and the moon looks dark, that can last well over an hour. And so you can go outside for a minute and look at it and go, oh, okay, and go back inside. Or if it's cloudy, you can try again in 10 minutes or whatever. But a total solar eclipse is much shorter. They only last a few minutes. And you have to be in a certain spot. When the moon's in your shadow, as long as you're on the side of the Earth facing the moon, you can see it because the event's happening out there. But a total solar eclipse happens here on the ground, and it moves very rapidly. And so you have to be in the right place at the right time or you miss it. So that everything about this makes it special. Very cool. So let's talk about playing Scrabble and how to destroy your opponent with a very high scoring word. This is a syzygy. It's also fun to say. And it's a weird word, but it actually, this is what an eclipse has to be. It's literally when you have 3 or more astronomical objects in a line. And it's relatively rare when you're talking about the Earth and the Moon and the Sun, but it does happen all the time, in fact, in the sky, because right there's a picture of Saturn, and at the upper right is its giant moon Titan, as big as a planet. There's another moon on the left there. You can see it casting its shadow. And there might even be, there's a third moon right on the edge of the planet. These are all considered a syzygy. You have Saturn here and a moon here and the Earth. And so when we look at Saturn, we're seeing a moon crossing it. That happens with Jupiter all the time as well. Its moons are constantly moving across the face of the planet. And so if you have space probes there or big telescopes, you can see these. Technically, they're not really eclipses. If you were on Jupiter The moon depends on the moon, but sometimes the moons are a lot smaller than the sun. I have to do that math. But if this happens on Mars, for example, its moons will pass in front of the sun, and the moons are too small to block the sun. So we don't call that an eclipse, we call it a transit. It's definition. It's pedantry, really, so I wouldn't worry about it. You can, if you want to think of these as eclipses, I'm not going to worry about it. So what do you need for a solar eclipse here on Earth? Well, you need three things. You need the sun, you need the Earth, and you need the moon. These are not shown to scale. 100 Earths can fit across the face of the sun, so the sun is quite large. And I took that picture of the sun, by the way, with a little solar telescope I have. I've taken 1,000 images of the sun, and they're mostly garbage, and this is the best one. You can actually see stuff going on, and it's really cool. Really, really hard to take pictures of the sun. As it happens, in our solar system, the Earth and the moon have a pretty interesting geometrical relationship, and that is the sun is 150 million kilometers away, about 93 million miles, and it's very large. It's 864,000 miles across, something like that. And the size it appears in the sky is the same as the moon, even though the moon's only a couple of thousand miles across and much closer, 280,000 miles away. I always get these numbers. I'm so used to thinking in metric. It's 384,000 kilometers, whatever that is in miles. It's really hard to use American units anymore after writing all these years. But it turns out if you do that math, that the moon and the sun appear to be the same size in the sky, very roughly. There are times it doesn't quite work. The Earth's orbit is a slight ellipse, so sometimes we're closer to the sun and it looks a little bit bigger, and sometimes we're farther away and it looks smaller. The moon's orbit is actually more elliptical, and it changes in size by about 10% over the course of an orbit, which is 1 month long. And so sometimes the moon looks bigger and sometimes smaller, but on average, the moon and the sun in the sky are the same size. And as it happens, because the moon is orbiting the Earth, it will sometimes pass in front of the sun, and that's how we get an eclipse. But before we get to that, we have to talk a little bit about the geometry here. So I've got this video that I stole from NASA. Actually, it's public, so that's fine. Now imagine this, for the middle diagram, imagine the sun is sort of up, and it's shining down on the Earth, and as the moon goes around the Earth, we see different parts of it being lit. This is all very sort of basic astronomy. When the moon is on the far side of the sun, there, when we look up in the sky, we see it completely lit by the sun, so we say it's full. When it's between us and the sun, there, we're looking at the dark side of it, just like if I hold my hand up, you're seeing it lit by those lights up there. You're seeing my hand full, but I'm looking at the back side of it that's not lit, so I'm seeing it dark. So it looks like it's new palm to me, I guess, and you have full back of hand. But that's how this works, and in between, we see different parts of it lit up. So it goes from new to crescent to half full to gibbous to full, and then reverse the other way around. And this happens every month as the moon goes around the sun. And so the question a lot of people ask, everybody asks this, I did when I was first learning about this, is, if this is the case, why is it we don't have a solar eclipse every time the moon gets close to the sun, and a lunar eclipse every time the moon is on the other side of the Earth and the Earth blocks the sun from the moon? And the answer is, the moon's orbit is tilted. And so sometimes, as it's going around the Earth, it's tilted by about 5 degrees from the plane of the Earth's orbit going around the sun. And I'll show you a diagram of this in a second that'll hopefully make that more clear. But the point is, as it's moving across the sky, if you were to stand in one spot and look out every time the moon passes the sun, it's usually passing below or above the sun. That's what it's usually doing. But every month, it changes a little bit. And so sometimes it'll pass directly in front of the sun. And it just has to be that the moon's orbit is tilted, and as we go around the sun, the geometry changes every month, and eventually, hopefully, the moon will be at the right spot in its orbit at the right time that it'll block the sun. And that's how this works. Here we're looking down on the Earth's orbit, that's in blue. Don't worry about the shading, that's not that important. The sun is off to the left there, and so it's shining down on the Earth, and the Earth casts a shadow in space that you normally can't see because space is dark. But if you have something that's not in Earth's shadow, it's lit up. And if you put it into Earth's shadow, from its point of view, the sun is blocked, so it gets dark. That's what a lunar eclipse is. And so there's that shadow there, and you can see the moon's orbit there in the white line. And this is all pretty much to scale. I think it is actually is to scale. The moon is really far away. It's kind of fun to hand people like a tennis ball or something and say, okay, imagine your head is the Earth and your tennis ball is the moon. How far away do you think it would have to be accurate scale to the real Earth and moon? And they'll be like, oh, I don't know, right about here. And it's like, no, it's actually like 30 feet away or something like that. The moon is very small and very far away. Even if you were to hold a dime in your hand, you can't hold it far enough away from your eye to make it. If it clears up next time and the moon's up, take a dime out and hold it up next to the moon, and you'll see, oh my gosh, the dime's much larger. The moon is very tiny. Anybody who's ever tried to take a picture of it knows that. It looks so big to your eye, and then you take a picture and you're like, it's 3 pixels across. What's going on here? It's very disappointing. So I can set this into motion. There we go. And so the moon orbits the Earth once a month. This is just, there's more going on here than you need to really know. But the good part about this is that we zoom in, and then we tilt it. Now we're seeing the Earth's orbit edge on. And now as you see, as the moon is going around the Earth, most of the time the shadow of the moon misses the Earth. But sometimes, if it lines up just right, the moon's shadow touches the Earth, and we get a solar eclipse. That's what that's showing you there. Can get in a little bit closer. Here's another one. This is actually for the 2017 eclipse. NASA has a lot of great videos that they have, and you can access them. They haven't put one together yet for the 2024 eclipse, so I'm using this one just as an example. But this is what the 2017 eclipse geometry looked like. There's the moon, almost 400,000 kilometers away, 200,000 miles or whatever. And its shadow is very, very long and skinny, and it passes right over the Earth that way. And if you all saw this eclipse, you might remember it moved sort of west to east across the United States, and that's what you're seeing there. This is actually a fairly complicated event. You've got the moon going around the Earth. It's not orbiting in a circle. It's got an ellipse. It's tilted. The moon is moving. The Earth is rotating. And all of these things add up to a complicated relationship with how the moon's shadow falls on the Earth. And so it tends to sweep a curve across the Earth. It's not just a straight line. And how long the eclipse lasts and where it is all depend on all of this stuff. And it's amazing to me to think that a couple hundred years ago, people could predict eclipses. And I'm thinking, it's hard to do it now. And we have computers. Now you can just look it up. But the actual math and physics involved is quite complicated. Also, in these drawings, you always see two shadows. It's one system of shadows. There are two shadows that you're seeing. There's one called the umbra, which means shadow, and that's where we get umbrella from. You hold an umbrella, you're casting a shadow over you. You're either blocking the sun or the rain, so it's like a rain shadow. And the penumbra, pen means adjacent to or something like that, and it's actually a lighter shadow. And you always get diagrams like this, which show that, and it's like, this is complicated and a little bit hard to understand, but basically what's happening is that if you're standing on the moon, I don't suggest doing that, unless you're sponsored by NASA and have a good spacesuit and a way home. And you look up during a lunar eclipse, what's happening is the Earth is blocking the sun. So the moon is orbiting around the Earth, and eventually it moves into the Earth's shadow. At first, the edge of the Earth just blocks a little bit of the sun, and it takes about an hour for the Earth to completely block the sun. And during that hour-long time, some of the sun is still shining where you are. And when the Earth is blocking a little bit of the sun, it only gets a little bit darker where you are. A little bit. You wouldn't even notice it. Until the Earth blocks most of the sun, where you're standing on the moon would look relatively normal. It's only when the sun really starts getting blocked, 90-95%, that it starts to get dark around you. And then when the Earth blocks the sun completely, you're in shadow. That is what you're seeing in this diagram. When the Earth is only partly blocking the sun, you're in part of the Earth's shadow called the penumbra. And it's only when the Earth completely blocks the sun that you're in the umbra. Now the sun is gone and it's dark. And the same thing is true for the Earth and the moon as well. In a solar eclipse, when you're looking up at the moon, you see the moon passing in front of the sun. It doesn't just instantly block the whole star. It starts to move across it, and it gets darker and darker where you are. You're in the Earth's shadow, but not the darkest part of it. That's the penumbra. That's the part in the bigger cone shown there, in the bigger blue lines. And it's only when the moon completely blocks the sun that you are now in the darkest part of the sun, the moon's shadow. Make sure I say this right. I don't think the sun casts a shadow, and if it did, there would have to be something much brighter than the sun nearby. And in astronomy, that's what we would say is bad. Something's exploding right next to us. And so if you're in the darkest part of the moon's shadow, the moon is completely blocking the sun. That's the umbra. And so that's what you're seeing up in these diagrams here. There the moon is partly blocking the sun for the penumbra. It's completely blocking it for the umbra. And even if you are an eclipse aficionado, you may not have ever heard of the antumbra, which I had not heard of until a few years ago. And that's where you're far enough away from the moon that it can't block the sun entirely. It's still blocking most of the sun, but the moon is too small. And so you get an annular eclipse, where the moon is blocking most of the sun, but you get a ring of light around it. That's why it's called an annular. An annulus is a ring. And I didn't know there was a name for that. It's called the antumbra. And I'm a word guy. I love playing with words. And so when I learned that, I was like, oh, that's cool. I like that. So you put all this together, what are you going to see? Well, again, this animation done by NASA for the 2017 eclipse, you see the moon very slowly moving across the sun, and this takes a while, typically about an hour, and it just gets darker and darker and darker, and then at the moment that the moon is completely blocking the sun, it's called totality, it's a total eclipse, and you can see the sun's atmosphere, what's called the corona. The sun is not solid, doesn't really have a surface. Astronomers have different ways of sort of kind of defining what the surface is, but it's not like you're standing on the ground, which is the surface of the Earth. But even so, because it's a gas, basically if you started from the center of the sun and moved your way out, it gets less and less and less dense, and then at some point it just becomes so low density that you can kind of say, I'm outside the sun now. But then for a long way out is its atmosphere, is this gas that surrounds the sun called the corona, and it's depending on how you want to talk about it, it could easily be millions of miles from the sun. And the sun is less than 1 million miles wide, so this is a big thing. And it's very, very faint. And you'll sometimes hear that it's like the corona is 3 million degrees. It's hotter than the surface of the sun, and everybody's scratching their heads about that. And it's like, yes, it is, but it's such a thin gas that what you think of as temperature doesn't really mean anything. Temperature is really just how rapidly atoms in an object are vibrating. And so if something is cold, the atoms aren't vibrating very much, and if they're hot, they're vibrating a lot more. And if you make them vibrate enough, they will leave that object and become a gas. And so you basically have this stuff surrounding the sun, but it is so thin that the atoms aren't really hitting each other. They're not able to shake each other up. So it has energy, but a temperature is not easy to define. And so if you just go by the math and say, yes, it's 3 million degrees, fine. But it's not like if you were in the corona, you would vaporize. If you could sort of remove the sun, because the sun is quite hot, as it turns out, and if you were in the corona, you would see this gigantic ball of fusing hydrogen in front of you, and that would burn you up. But if you could remove that, just being in that 3 million degree corona, you would freeze to death, because there's just not enough energy in it to transfer its heat to you. It's kind of similar to how you can reach inside an oven and the air is hot, but it doesn't burn you. But if you touch the side of the oven wall, you'll get burned instantly. It's how the heat gets transferred that's important, not just the temperature. So that was an animation, a diagram, a simulation. This is actual video taken from Australia. That's why the title's upside down. Hope you all are reading the titles, because I have a terrible sense of humor. And this is what you see. The eclipse is getting closer and closer and closer, and then boom, it becomes total. And when the bright sun is blocked out, you can see the base of the corona there. That can actually extend for a long way across the sky. You can block the sun out with your thumb. This whole image you could block out with your thumb. But the way this camera is exposed, you can't see the stuff that's farther out. But I'll show you some pictures here in a minute or two that actually that shows you exactly what's going on here. Taking video like this is not simple, and I'll talk about that in a couple of minutes too. You know what? I'll just leave it. I'll talk about that in a minute. So these are all past eclipses and everything. So April 8th, 2024. There is an eclipse in 2023, but I don't think you can see it from here. There's a great book here, and I've got some, as a matter of fact, the next diagram I'm going to show you is actually taken from a website. This is Michael Zeiler and Michael Bakich, The Field Guide to the 2023 and 2024 Eclipses. This book is really, really cool. It comes with eclipse glasses, which I'll talk about in a few minutes. Tells you all about the eclipse and has these are detailed maps of the path of the eclipse on the Earth. So yeah, the 2023 is an annular eclipse. You see it going across Texas. Actually, it gets pretty close to here, doesn't it? Does anybody know? I don't know. San Antonio? Oh, it's pretty far west of here. I was wondering if it moved east-west. It was more north-south. But anyway, if anybody wants to take a look at this, you can take a look at it later after the talk. But it has great maps of the 2024 eclipse coming up. And so that the 2023 eclipse happens when the moon is farther from the Earth than average, so it can't block the sun completely, and that's going to be an annular eclipse. Never seen one. I've seen a ton of partial eclipses. And then, like I said, until 2017, I'd never seen a total. But I've never seen an annular one. I think that would be really cool. I don't know if it's really worth driving to the wilds of Texas to see, maybe, if you're into that sort of thing. But for me, that's a long drive. So April 8th, 2024. The path of the moon across the Earth is going to look like this. The big circle is the penumbra, where anybody inside that circle will see at least a partial solar eclipse, where the moon partially blocking the sun. The closer you get to being in the center of that circle, the darker it gets, until you're right in that path where the umbra passes over the Earth. So again, complicated. The moon is moving, the Earth is rotating, so it makes this little S curve, an integral sign, as it passes over the Earth. Very inconsiderate of it to not pass over Colorado. The last one didn't pass Colorado either, but it did go over Wyoming. So my wife and I actually drove out there to see it. And I'll talk about that in a minute. And this gives the duration. If you're right in the center, you can see that it's lasting about 4 minutes, 4.5 minutes. And up there it's giving the time in universal time, which is basically British time, Greenwich time, and Central in April with all the time zones and daylight saving and everything. I have no, that's like 17 o'clock in the morning. I don't know. But of course, it's a solar eclipse, and if you're going to see it, it's during the day. That's how these things work. So you know it's going to be at a decent time. So there's the path. Here's a nice flat map done by my pal Fred Espinac, who's Mr. Eclipse. He is just a genius with eclipses. If you look his name up, you'll find tons of information about eclipses. And the path starts way over here over the Pacific, moves up over Mexico and across the U.S. The 2017 eclipse, I think, passed over more big cities. So it was potentially seen by more people. This one doesn't pass over as many big cities, but it does pass over Arkansas, and that is convenient for you. And so here is the local path, and here. Right, there's Little Rock. Right there, just so you can see it. Unfortunately, the central part of the eclipse doesn't pass over Little Rock, but those blue lines, as long as you're between those blue lines, you see a total eclipse. If you're right on the edge of that blue line, the sun and the moon passes right over the edge of the sun, so you get a total eclipse that lasts for like 1 second. And if you're outside of that, the moon doesn't completely cover the sun. So you could almost literally like stand here and see a total solar eclipse and then run for a few seconds in another direction and not see it and only get a partial. The line's fairly sharp. I don't know exactly how sharp, but in principle, that's kind of the idea. And the red line is the center line. That's where you want to be to maximize the eclipse. You don't have to be right on that red line, but the closer you are to it, the longer it will last. And Little Rock, unfortunately, is towards the edge there, So if you were to just basically drive to the northwest, or if you want to drive farther to the northeast or southwest, anywhere that red line is, that's where you want to be. If you want to zoom in even more, there we are. That's actually the position of the theater, the blue label. The center line is again to the upper left of the northwest. And this is the prediction is again by Fred Espenak. If you look up like Google Map solar eclipse Espenak, you'll find this. And you can click anywhere on the map and it will calculate how long the eclipse lasts, the duration. So if you were to stand right here and keep yourselves parked in this theater for the next year and a half and look up, the eclipse will last 2 minutes and 23 seconds. There's a lot of information in this that's not hugely important, but it tells you when it starts, when the partial eclipse starts, when the totality starts, and all of that. The partial eclipse is kind of neat because you can watch the moon, right, take progressively bigger chunks out of the sun. You won't really notice what's going on around you until the eclipse is nearly total. And you know what, I'll take a minute and talk about that now. I've read a ton about eclipses, and have seen a lot of partial eclipses from places I've lived in this country, and never seen a total eclipse. My wife and I run a science vacation company, which is on hiatus until the pandemic's over. But one of the last ones we did is we took a group of people to Wyoming, to Du Bois, if you've ever been there, a small town in Wyoming, and camped out there for a week. And the eclipse was on the second day of this week-long thing we did. And I was experiencing my first total solar eclipse, like almost everybody else there. And it was weird. It's really a strange event. People had telescopes and cameras and everything set up. And when it first happened, I'm watching I knew exactly where we were. I had all the timings down and everything. And I'm watching my phone, and it's like, okay, the eclipse is starting right now. And everybody's like, okay. And I could have said anything, and it wouldn't have mattered, because you just don't notice when the moon first touches the sun. If you have a telescope that's properly equipped, you would have just seen a little tiny nick taken out of the sun. But over time, of course, we're seeing more and more of the sun block. But even at half, it was like maybe a slightly overcast day, but you really didn't seem any different. But then at about 90%, and people write about this, but they don't describe it very well because it's hard to describe. The light changes, and it felt like it's walking from outside where you have natural daylight into a room that's lit by fluorescent bulbs. The light feels different. And it's because the sun, one reason is because the sun is this disk in the sky. And so it doesn't cast a sharp shadow. For the same reason the moon doesn't cast a sharp shadow. You have the penumbra and the umbra. If you were to look at your shadow on the ground on a daylit, at noon or whatever, the edge of your shadow is a little bit fuzzy. Because if your shoulder is blocking part of the sun, right, just outside of your shoulder, that part of the ground is still seeing the sun, and so it fills in the shadow a little bit, and the edge is fuzzy. But as the moon starts blocking the sun and the sun gets thinner and thinner to where it's a crescent, it's more like it's a point source, just a dot in the sky. And your shadow gets sharper and sharper. And it feels weird. You're cognizant of it, but you're aware of it, you just don't really know what's going on, just that something's different. And everybody was like, this is weird. And then it does start to get dark. The sky darkens. It's like twilight. For a while, the sky starts to turn darker and darker blue. And then when it's totality, and we were all looking at it with our eclipse glasses, and it's amazing. And then suddenly it was total for about 2 minutes. And that was amazing because you could hear the crickets chirping, the birds stopped singing because they're like, oh, it's dark, time to go to bed. And I don't remember exactly what planets were up. I want to say it was Jupiter and Venus, but you could see them. It's flipping noon. And it's like, there's Venus, and like, there's Jupiter, and you can see a couple of stars. It was amazing, and it only lasted for 2 minutes. I had it timed down. I told everybody, okay, stop looking, put your glasses back on, and then like 3 seconds later, the sun popped out. I'll talk about all that in a sec, too, about why. let me show you some pictures of this to show you how this works. This is a very common way of showing an eclipse, where somebody takes their camera and puts it up, just fixes it in the sky and takes a picture every few minutes, and you can see from sort of the bottom right moving up to the left, the more and more and more of the sun is blocked, and then boom, you see the corona, and then that's over in a few minutes. So this is, you can think of this as like a time exposure, a series of exposures taken every few minutes. And this is a great way of showing the progression of the eclipse. See images like this all the time. When the eclipse is total, amazing things happen. First of all, you're seeing the dark side of the moon, so it's almost perfectly pitch black. I've seen some images where you can actually see some features on the moon. But how is that possible? What's it being lit by? Earth, right? You go out, you look at the new moon or a crescent moon, and you can kind of see the dark side of the moon a little bit. That's called the old moon in the new moon's arms. I love that. That's so poetic. We call it earth shine, which is also a lovely term. Basically, if you're on that part of the moon that's facing away from the sun, and you look at the earth, in your sky, the earth is full. And so the earth is physically 4 times bigger than the moon. And that means it has 16 times the area square the size. So it's right away, it's 16 times brighter than the full moon. But it turns out the moon is kind of dark. It's really a dark gray, like slate. Not quite that dark, but dark. And the earth is very reflective. And so all said and done, when you do the math, the full earth is about 50 times brighter than the full moon. So for the moon, even though the sun is you're not seeing the sun in your sky, the earth is so bright that it actually fills in a little bit of that. And if you take a longer exposure during the totality part of the eclipse, you can actually see some of the features of the moon. And a lot of people will do that. They'll make a composite where they'll take a short exposure like this and the longer exposure and put them together. And it's beautiful. And so here you can see the corona, the misty atmosphere of the sun. But you're also seeing all of those red things. Those are eruptions on the sun's surface called prominences. The sun has a very strong magnetic field, and the surface of the sun, the surface, quote unquote, is a plasma. And what that means is the gas there, mostly hydrogen, has its electrons removed. And when you do that, when you have a charged gas like that, it reacts to magnetic fields really strongly. And so it flows along the magnetic field lines of the sun. And you've probably seen pictures with those gigantic loops and things of the sun, and that's what you're seeing here. And these things are immense. I mean, these are thousands and thousands of miles high. Remember, 100 Earths would fit across the sun's diameter. So these things are clearly much larger than the Earth. And if the moon is just the right, if the moon is too close to the Earth, you sometimes don't see those because the moon is big enough in the sky to block them. But if it's at just the right distance and the sun's just the right distance, you can see those. And it's lovely. They're red. They look red. When you look up at the sun and you see this, I was shocked. And you're just like, oh, there's a couple of them there, and they were red by eye. Very, very cool. Here's a picture by my friend Tunk Tezel, who kindly let me use some of his images. This was taken in Svalbard, Norway in 2015. And this is a great shot because you see people in the foreground, these beautiful snowy mountains and the total eclipse. What's interesting is on the left, the sky is still kind of bright over there. And that's because if you were to jet over to that direction, they'd be seeing a partial eclipse. And so for them, the sky is still a little bit bright. And you can see sort of the edge of the eclipse moving across the sky there. It's not easy to see that, but you can. And especially from airplanes and stuff, you can see that as well. And you can see like this dark cone where you're in the shadow of the moon. And on either side, the sky is still blue. And if you were to go over to those spots, they aren't getting the total eclipse, but right where you are, they are. It's lovely. Here's another one, partly cloudy. This is again by Tunk, taken in Uganda in 2013. It's taking pictures. I'll talk about this in a minute. But when you're taking pictures, a lot of people just want to get pictures of the sun. They want to zoom in on it, and I say, you don't have to do that. You get these lovely, cool pictures like this if you use a wide-angle lens. And here is exactly that effect. This is the Queensland, Australia eclipse again that I showed you the video of earlier, again by Tunk. And you can see it here, where the shadow of the moon is this cone in the sky, and on either side you're seeing the sky being lit by the sun because they're not getting the total eclipse. I love this. That's just such a cool effect, and you hardly ever see it in photos. And so if you are going to take pictures, I would suggest using your imagination. Here's that same eclipse, very, very near the end of the, I think near the end of the eclipse where the edge of the sun is just starting to come out again. And it was a little bit cloudy, but again, you can see those prominences and the different loops and the bright edge of the sun. Sometimes during a total eclipse, well, let me say it this way. The moon is not a perfect sphere. You've seen pictures of it. It's lumpy. It's got mountains, it's got craters, it's got valleys. And if you're seeing a mountain on the edge of the eclipse, that mountain might be blocking some of the sun, but on either side of it, the sunlight's still getting through just before the eclipse is total. So the only thing really blocking that ring of light, the very thin crescent sun, is that mountain. And so you'll see like a crescent with a hole in it. And as that moves in, smaller and smaller hills will block the sun as well. And you get what's a broken arc. I don't have a good picture of it here. But you get a broken arc, and it's like beads of light. Those are called Bailey's beads. Because a guy named Bailey who figured out what was going on there. And it turns out this is a phenomenal effect. We didn't get it for the last one, at least not that I noticed. But if that happens, it's really cool because it's like a string of pearls. Beautiful. And it only lasts for a few seconds. So you really have to be on top of your game to see it. So I want to talk about photography here for a minute. Because I'm kind of a chucklehead sometimes when I do stuff. Years and years ago, I worked on a camera on Hubble, and it went up to the telescope. Astronauts took it up in the space shuttle. And so we went to Florida to see a space shuttle launch. I'd never seen one before. And I was very excited, very cool, seeing this from 5-6 miles away, and I've heard all the stories. It's very similar to an eclipse. You hear all these really cool stories, but you just can't experience, you have to experience it to really understand what's going on. And a friend of mine said, listen, I've been to dozens of shuttle launches. He said, don't take pictures. Watch it. Just watch it, experience it, let it wash over you. There will be 1 million people around you taking pictures. You will find them on the web. And even so, because I'm stubborn and silly sometimes, I took pictures. And it distracted me. I wasn't paying attention to what I was experiencing. I was paying attention to my camera. The pictures came out fuzzy. I couldn't focus them. So not only did I not get the full experience, I didn't even get the pictures as a trophy out of this. And of course, now you can look it up. It was in '97, and there were 10,000 people there taking pictures. And, yeah, sure, it's not your picture. You didn't take that specific picture. But I don't think ownership of a photo is enough to abrogate the experience. Don't miss the experience. Go outside and just watch. But, having said that, it is now possible to have a camera rig that you don't have to fuss with. You can get it all set. When we went to the eclipse in Wyoming in 2017, one of our folks had a camera on a tripod that was completely programmed to take pictures the way he wanted it to. So he knew that the sun was going to be in the frame, and he programmed it to take a picture every 5 seconds or something like that. And he wound up making this really cool video that the camera took without him messing with it. And so he was there watching it and experiencing it. And that's the best of both worlds. And I'll get back to that. I'll get back to that in a minute because I'm going to talk about how to watch it. But I just want to. I strongly urge you. You're going to want to take pictures like this. Unless you're super experienced, don't. Honestly, don't. Just go and see it. And one of the reasons is because of my next photo, which may surprise you. You'll miss something. There's stuff going on during a total solar eclipse that is not the sun in the sky that is worth looking at. Sometimes it's worth looking at the ground. Because in this picture, the sun is shining through trees, and the leaves are overlapping, and some of the leaves have holes in them, and they make a pinhole camera. And the shadows that they cast on the ground are all crescents, because that's what if you were to look up and see the eclipse at that moment, you would have seen a crescent sun. But it's the same thing as a pinhole camera. And during the last 15 minutes or so before totality, when I was with my friends, I was saying, here, just do this. Just, make a tiny little hole by curling up your finger and then looking at the shadow of your hand on the ground, and you could see the crescent sun, because when you have light passing through a very small hole, it acts a little bit like a lens. The physics is kind of similar, and you wind up getting a focused image. And so you can, it's a little blurry, it's not perfectly focused, but you could easily see what the sun was doing by simply making a little hole in your hand. And people were doing stuff like crossing their fingers and fiddling with it, and it's fun. And you've got several minutes before the eclipse is total to do that. It's really cool. And to see something like this, it's weird. Trust me, you've not seen anything like this. And so the point is, not all the action is going on in the sky. Look around you. And like I said, the light gets weird, and it's strange. So how do you observe this? What's safe? I've heard stories, if you look at an eclipse, you'll go blind. And it's like, no. There has never been, and I'm going to be very careful with my wording here, there has never been a case of somebody looking at an eclipse and being totally, permanently blinded, okay? The problem here is that during the total part of the eclipse, you can just look at the sun. It's fine. It's all blocked. It's dark, and it's fine. But even if the moon moves off a little bit, that part of the sun, that sliver of the sun that you see, is not nearly as bright as the total sun, but it's still intense enough that it can damage your retina. And so people looking at an eclipse without safety measures taken, you can get little tiny spots in your retina burned out. Not the whole thing. You'd have to like scan the sky and back and forth looking at the sun to do that. And even then, the damage can heal. It's not necessarily permanent. So to be completely permanently blinded by looking at an eclipse is almost literally impossible to do. However, being partially blinded by an eclipse, not a great thing. Don't do it. Don't look at the sun until it's safe to do so. But then once you're in total eclipse, it's safe and you're fine. But that's why I had my phone set. I had a stopwatch set to 2 minutes and 20 seconds or whatever, so that it would beep at me, and then I could tell everybody, okay, stop looking, put on your glasses. So how do you look at this? During the eclipse, whatever you want. You can look at the sun through a telescope if you want. Don't recommend that necessarily, because if your timing's off, not only are you looking at the sun, you're focusing the light of the sun on your retina. And if you want to blow a hole in the back of your head, that's a decent way to do it. You could get these eclipse glasses. A lot of places will sell them for $1 or $2. I bought a package of like 50 for like $50 and gave them out to people. As I was driving to the eclipse site, remember this is like the day before the eclipse, there were people camped out on the highway in Wyoming selling them for like 20 or $30. And I thought, oh, I messed up. I should have bought 1,000 of these, and I'd be rich. But yeah, you can get them for a couple of bucks. Like I said, if you buy this book, The Field Guide to the Eclipse, one comes with it. And museums can give them away.
Just to say that ASGC is purchasing several thousand of these eclipse glasses and will be giving them out to schools all around the state.
For $100 each, right? No, okay. Yeah, they're made of a. The thing is, the sun is actually very bright, and so you want to block that light as much as possible during the partial phases of the eclipse. And so these have a thin, dark film in them, and it blocks the light. And you want to make sure there were a bunch of knockoffs made by, I want to say China or Russia, someplace, that were not safe. So they were dark, but they weren't safe, and I'll get to that in a minute. So you want to be very careful and make sure you get them from somebody that there's a rating that you can find that says the U.S. government stamps it and says, yes, these are fine. This is a photo of my solar telescope. It's heavily filtered. I've used it to look at the sun during the day all the time. That's the picture I took that I showed you much earlier of the sun. The pink one, the reddish one, was taken through this telescope. It's wee. It's little. It's about this big. But that's a fine way to look at the eclipse. Celestron and various other telescope companies make filtered binoculars. Eclipse Smart is the brand that Celestron sells them under. They're relatively inexpensive. Bear in mind that you cannot go stargazing with them at night. They are heavily filtered to block the sun, so you're not going to see anything else through them. You can actually use them to look at a light in your room and you can barely see the light. So they're for the sun. Another way, I've done this many times, is to use binoculars, not to look through them, because again, that'll boil the liquid in your eyeball, so don't do that. But if you set them on a tripod and point them at the sun, and you can look at the shadow of the binoculars on the wall or on a piece of paper to figure out when you're pointing at the sun. I recommend blocking one of the lenses, so you only have one image of the sun. And you can project it onto a piece of paper or a wall. It's not great for your optics. The sunlight is still hitting the back end of your binoculars, and the back end can get very hot, and that can damage the optics. I didn't use a very expensive pair for this to make sure if I lost them, I'd be like, oh well. But I wanted to get pictures of sunspots because there were some big sunspots that day. That is a perfectly safe way to do it, even though you might screw up your binoculars. And the absolute safest way is to look at it on a computer, right? Let somebody else take all the risk and the expense and everything, but you're not seeing it for yourself in that case. Still, if it's cloudy and you can't get to a place where it's not cloudy, you'll miss it. And that's unfortunate because the moon's shadow is so narrow that, yeah, I mean, you can, if it's cloudy where you are and it's clear 50 miles away, they may get it and you may not. Which is one of the reasons we picked Wyoming, because it was in August, and Wyoming is cloudless in August all the time, so we knew we were really, really good chance. Here in Arkansas, beats me. In April,
Very iffy.
yeah, I would think it's iffy, so you might want to travel. It does pass through rural Texas, where it's more likely to be clear. Eclipse cruises are a thing. And that's really cool because if it's cloudy in one spot in the ocean, they can just go to another spot and be there. You can also charter plane rides. There are astronomers who do this. A couple of friends of mine do this. It will cost you dearly. These are in the $10,000 range. But the beauty of that is not only are they above the clouds, so they don't have to worry about clouds necessarily, or they can go someplace where there's not clouds, but they can travel at 400 or 500 miles an hour in the same direction as the shadow and turn a 4-minute eclipse into a 5-minute eclipse, for example, or a 6-minute eclipse, depending on the geometry and all of that. So yeah, I mean, that's pretty cool. The only other problem is, of course, if you're on the wrong side of the plane, you're not going to see it. So yeah, so they charter it so that everybody can look out the window and see it or take turns or whatever, and you have plenty of time. And that's really cool. I like that idea a lot, but it's expensive. So there are a lot of different ways of seeing the eclipse. There are a lot of ways of not seeing the eclipse. These are no-nos, okay? Don't buy a telescope that says, we have a solar filter that fits on the eyepiece, right? You have one end of the telescope that light's coming in. All that light is coming in and being focused into the eyepiece that you look through. And these eyepiece filters are usually glass and they're dark. They might even be plastic. But they can melt. I mean, you're concentrating all of that sunlight onto this thing and blocking it at the wrong end. You want a filter that fits at the front end of your telescope, and that can be something that blocks most of the light. And again, these are not expensive. If you have a telescope, you can probably find an eclipse filter that fits at the front end. There are stories of these solar filters shattering. I mean, if they're made of glass, they can shatter, and your eye is right next to that. Okay, that's another great way to go blind during an eclipse. I should say, maybe there is a permanent, total way of going blind during an eclipse, and that's cheaping out and buying bad equipment. Do not do that. Some people say you can use a DVD and look through that. The problem is the sun emits more light than just the kind of light we see. It emits ultraviolet and infrared light. These things don't necessarily block that light. And the infrared light can actually cook your retina. So people used to take film, that's another one here. I put that on there for historical reasons, like anybody has a roll of film anymore. But you could use unexposed film. You just pull it out of the cassette. Kids ask your grandparents now, I suppose, about that. And you can take multiple layers of this and hold it up. The problem is that lets through infrared light, and that can still damage your eye. You don't want to do that. And just to let you know, I used to roll my own film in my bathroom, so I am the old as well. And some people say mylar, and that's dangerous as well because it may not be thick enough, and mylar is infrared transparent as well. You do not want to fool around with this. We are talking about your eyeballs, okay? Absolutely make sure that what you're doing is safe. Buy it from telescope makers like Celestron, Orion, or somebody like that. Look them up online, make sure that they're legit, and you'll be hopefully safe. Seeing this event, if you can, by God, drop everything you're doing and go see it. Like I said, I've seen exploding stars through a telescope, galaxies, planets. I watched the moon pass in front of Venus once. I've seen all kinds of stuff in my many, many decades at the eyepiece. And I had never seen that total solar eclipse until 5 years ago, and it was life-changing. And I told my wife this. She's not an astronomer. She's astronomy adjacent. And has heard all my stories, and you can just, her eyes physically roll back in her head whenever I start talking to her about this stuff. And I was telling her every story I've heard is that people get emotional. There are people weeping when they're seeing this. And I'm getting choked up just thinking about this event again. And she was like, yeah. And then afterwards, she was like, that was one of the coolest things I have ever seen. She's not a getting choked up, weeping kind of person. But still, she was clearly moved by this. And I was, even though I was freaking out about making sure everybody was safe and trying to do all this, I was transfixed at the moment of totality. To see the sun go away in the middle of the day is strange. To have it go so slowly, and to have, and I was thinking about this. It's like, you know, if the moon were much bigger and moved faster, for example, around the Earth, then that partial eclipse state wouldn't last very long. And the thing is, part of the event is this teasing. Things are getting weird. And you're feeling different, and everybody's like, what is going on? You're already excited about it, but the sun is then giving you, it's like a well-scripted movie where they sort of teased until you get to the big event. When you get to the big event, you're like, yeah! That's what this is like. And so just this huge, overwhelming feeling of awe, just being there and seeing it. I have never experienced anything. I mean, the birth of my daughter. It's in that category. I mean, not as high. My daughter might actually watch this someday. So, no, hon, it was fine. You were the best. But the eclipse is pretty close. It was very, very, very cool. So if you can do it, please take this opportunity, because there won't be one in America again for a while. These things, you know, like I said, it depends on where the moon is in its orbit. Sometimes they happen on the other side of the Earth, so it's night where we are, and they get the eclipse. And so, yeah, you just want to see it. And I'll leave you with this. My friend Katie Mack is an astrophysicist on Twitter. She's quite funny. And you may have seen versions of this, but she was the one who did it first. And she used emojis, right, to show if the Earth is between the sun and the moon, you get a lunar eclipse. When the moon's between the sun and the Earth, you get a solar eclipse. But if the sun's in between the moon and the Earth, that's apocalypse. And I get sometimes people ask, you know, when I talk about eclipses, they say, okay, so is the moon between the Earth and the sun, and the Earth between the moon and the sun? What happens if the sun is between the moon and the Earth? And I say, well, think about that for a second. That can't happen, right? The sun's here, and the Earth and the moon are over here going around each other, so that can't happen. Also, the sun is actually quite a bit larger than the distance from the Earth to the moon. So we would actually be inside the sun if this were to happen. And even if the sun were small, this would still be a problem. Having the sun 100,000 miles away instead of 93 million would be it would be apocalyptic. It would be an issue. So happily, this doesn't happen. But we are very lucky that the moon and the sun appear to be the same size in the sky. There are other places in the solar system where this is possible. But the fact that it happens on our planet is already cool and interesting. It's a coincidence. But it's absolutely a coincidence, but it's still pretty neat. But to have all of these things line up the way they do, literally line up the way they do, and to have it not happen if this happened every 2 weeks, you'd be like, oh, eclipse, right? But because it's precious, because unless you travel a lot, you may not even see one in your lifetime. I was 50-something when I saw my first one. And so to be able to even get a chance to see something like this makes it that much more precious and rare and wonderful. And we toss the word, awesome around a lot. But this really is awe-inspiring. And so please, 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 you're right here in one of the best spots on the planet to see it. Take that chance. Thank you very much. As I slowly lose my voice. I do not. I'll just stand here. Or do you need the mic to hand to people? I can repeat the question. And let me just say while we're talking, the Fred Esmax Mr. Eclipse, what a great URL to get that. NASA has an eclipse site. GSFC is Goddard Space Flight Center. There's the Great American Eclipse website, which has tons and tons of information. And just to plug myself, I have a newsletter which is free on Mondays, and I have a paid subscription on Tuesday and Thursday. But that's badastronomy.substack.com. It's not just astronomy, it's also jokes and movies and nerd stuff and politics and everything. But if you want to sign up for that, I'd appreciate it. Okay, so I'm happy to answer questions. Apparently it was a perfect talk. You understand everything. Oh, okay, yes.
I was wondering, where would you have to be on Earth to see the Antumbra?
Where would you have to be on the Earth to see the Antumbra? It's how do I explain this? It's always out there. So if you were in a rocket, you could go out past the Earth a little bit in the opposite direction of the moon, and eventually the moon would shrink enough that you get that. But anytime there's an annular eclipse, that's what you're in. You're in the Antumbra. And so, next year during this annular eclipse, if you're, I guess, in Texas or wherever else it's going to be, if you see an eclipse like that where they say this isn't a total eclipse, it's an annular eclipse, that's an antumbral eclipse. And there's some amazing photos and video. There was one, I want to say it was in Turkey, where, or China, and a woman took images of the sun rising. The sun rose in eclipse, and so you see this sort of crescent that's distorted by the Earth's atmosphere because you're looking right at sunrise. And you get all these weird optical effects, and these images are just gorgeous. And so even an annular eclipse would be quite a thing. It wouldn't get that dark, but it would be really interesting to see that, especially if it's happening at sunrise or sunset, and you get all those cool things as well. Hopefully one day I'll see one of those too. I just have to live another 80 years. Yes?
So a while ago I read somewhere that the moon's slowly drifting away.
Yes.
So when would it be, is there a prediction or something like that as to when the last solar eclipse would be, the moon's so far away that it doesn't work?
Right. I do not know this person. I did not pay them to ask this question. But in fact, that was something I was saying, that it's a coincidence. And some people like to say that it's miraculous that the Earth and the Sun and the Moon are the same size. And it's if you want to believe in miracles, that's fine. But this is not that. This is not one, because when the Moon first formed, some planet smacked into the Earth back when the Earth was only 100 million years old or something, blasted all this junk into Earth orbit, and that formed the Moon. When it formed, it was very close to the Earth, very, very close, like 20 times closer or more than it is now. And over time, the gravitational interaction between the Moon and the Earth has moved it farther and farther away. We can see this in the fossil record. There are, like in the ocean beds, seabeds, there are like algae deposits that depend on the tides and how long it takes the Moon to go around the Earth and things. And you can see that those layers show that the Moon was orbiting the Earth much faster back then. It was closer to us. And even today, the Moon is moving away from the Earth by about 4 centimeters a year, about this much. That is measurable because the Apollo astronauts left mirrors on the Moon that you can beam a laser at, and that's reflected back to the Earth, and you can pick that up. And by using the well-known speed of light, the time it takes to get to the Moon and back, divide that by the speed of light, and you get the distance to the Moon, and you can measure that. And sure enough, the measurements are precise enough that we can see that the Moon is moving away by about that much a year. That's the same rate that your fingernails and your hair grow. So just to give you an idea of how it's not a fast thing. So it is moving away. So if you think about it, a couple of billion years ago, the moon was huge in the sky, like your fist, and would block the sun quite a bit. Eclipses were probably very common. Even though its orbit is tilted, it would have blocked the sun more often. Now it's moving farther and farther out, and eclipses are becoming more rare. And right now we're at just the right spot where we get these beautiful total eclipses. But over time, the moon's going to move farther and farther away until one day there's going to be the last total solar eclipse, and then every eclipse after that's going to be annular. When that happens is actually really hard to figure out, to get to the answer to your question. The rate at which the moon recedes from the Earth depends on a lot of stuff that you would not expect, like the shape of the continental shelf. Because the moon exerts tides on the Earth. It's pulling on our oceans. And sometimes the speed of the moon around the Earth can sort of couple with the Earth's rotation, and they help each other. Like when you're on a swing and you kick your legs in time with your motion, and you can pump yourself up faster and faster. It's very, very similar effect. And sometimes the moon recedes more rapidly than other times. And so predicting that in the future is really hard, especially with sea level rise now. And so it's hard to say. I like to tell people we're in the middle of about a billion-year-long eclipse season. And when that season is over, it's over. It will be many, many millions of years before that happens. Maybe even hundreds of millions of years. So to answer your question is, do you have to worry about that? Probably not. But, it is a thing. And it's an interesting thing to have to try to figure out. Even if, like we try to figure out when the sun's going to turn into a red giant. It's not going to do that for 7 billion years. But to know exactly when it's going to happen is something of scientific interest. So I'm sure there are people trying to figure that out, but I think in the end it's like you just can't know. Even an ice age would hugely change that rate. So I don't think it's possible to do it. Are there any other questions? None of it. You have a question. Good.
The thing that got my husband and I interested in astronomy is how the universe works.
Never heard of it.
And we were fascinated by it. Do you have anything else in the works?
Well, thank you very much. Again, I do not know this person. How the Universe Works is a television show on the Discovery Network's Science Channel. And the 10th, and it's unbelievable, the 10th season of that show, the first half of it is already aired. If you have like the Discovery Plus app or something, they're all there. The back half of the season, there's still 5 episodes that haven't aired yet, and that got delayed by the Warner Brothers Discovery merger that's messing up everybody's favorite TV shows on HBO and everything. That corporate merger was a mess, apparently, and it's just really, really hard to get everything straight. So I'm hoping that the last 5 episodes will pop up in December or January. We have not filmed an 11th season. I haven't heard anything about that. But COVID has made a hash of this. It's an English production. It's an English production company, and they come to the States to film it and everything, and travel. The last time the COVID protocols were difficult, so I don't know when there's going to be an 11th season. It'll be at least a year because it takes a year to make the show, and I haven't done a whole lot of TV since then. But thank you for asking. I do have a newsletter. And I'm now writing an irregular column for Scientific American. And by that I mean it's not like every week or something like that. It's just when something cool comes up and I write about it and they put it online. But I also have a book coming out next year. I try to make it a good solid 10 years between books. That gives me a good refreshing vacation from living chained to my computer. And it's called Under Alien Skies. And it's about what astronomical objects would look like if you could go to them. And it's a little bit different because it's like, what's it like to be on the moon? And I actually talk about what it's like to see a lunar eclipse if you're on the moon when the Earth is blocking the sun, because it's quite a bit different than a solar eclipse as seen from the Earth, and it was a lot of fun to write about. Saturn's rings, what would it really look like if you were in a ship sailing over Saturn's rings? Planets around binary stars, 2 stars orbiting each other like Tatooine, or in a globular cluster. What's it like to be in a nebula, a gas cloud? I read a ton of journal papers until my eyes were just dry as salt cubes, to make sure I got as much of the math and physics right as I possibly could. But none of that is in the book. It's all descriptive, it's narrative. It's like, what will you see? What will you feel? What will it be like to be in these places? And it was a lot of fun to write, and I hope people like it. And that comes out in April. W.W. Norton Publishing. And it's available for pre-order at your favorite online bookseller if you want to order a copy. But that's all I have.
Speaking of books, Bill has 2 books out currently, and one is his first one, Crash Course Astronomy. We could not get into the lobby tonight, so. But we do have Depth in the Sky, so speaking of what-if scenarios, in that book, Bill takes a lot of what-if scenarios and kind of expands on them as to, what would happen if we were a supernova.
I always thought it's basically about, all the different ways that astronomical events can wipe out life on Earth. It's an uplifting, feel-good family book. I tried to make it, it gets a little grim in spots, so I tried to make it as fun as possible, but people would always ask me, do you write about asteroid impacts? And I'm like, oh, that's chapter 1, my friend. When you get to chapter 6, but the good news is most of these things can't happen, and as we just showed with the DART mission a couple of months ago, NASA was able to impact an asteroid and change its trajectory. So hopefully we can learn from that and figure out how to prevent asteroid impacts. But that's so it's a science-based book, but it's about all the different ways that can happen. And
it's a fun read. You'll laugh, you'll cry.
And you've got it on sale out in the lobby?
Yeah, it's on sale out in the lobby, so after we're done here, Phil will be signing the book.
It's a brilliant book. It'll be the best thing you've ever read. Until next April. Oh, there is a question. Oh, wow, over there, I see. Yes, go ahead.
It's just about the heat plane. If you have any information, if it's changing, it's decreasing or increasing, or it's constant. The heat plane that you mentioned, that is 5 degrees.
Right. The orbital tilt. You want just more information on that?
Yeah, if it's constant or if it's actually changing.
Oh, I see what you're asking. Okay. I'm sorry, I misunderstood what you were asking. It is more or less constant. I have to think about that for a minute. I don't know for a fact, and I don't want to say something wrong, but it's at least more or less constant at about 5 degrees. Things change a lot. Like you're probably taught that the Earth is tilted by 23.5 degrees from its plane of its orbit, and it turns out that actually changes. It's sometimes it is 23 or 24, not like year by year. This takes thousands of years to change. And the moon's orbit changes shape a little bit because it's being tugged on by the sun, and even Jupiter has an effect on that. And the Earth's orbit actually changes over time. There are these things called Milankovitch cycles. When you go back in the past and look at ice ages, they line up with the same time that the Earth's orbit was being changed by the effect of the other planets. And that in that case, you're talking about events that take hundreds of thousands or millions of years, so it's not something you have to worry about. So over time, I will absolutely guarantee that the tilt of the moon changes at least a little bit, but in the short run, like over our lifetimes, not enough to worry about. If you are trying to go to the moon, if you're NASA or the European Space Agency or whatever, and you want to send probes to the moon, you want to know that number as accurately as possible because you're sending a rocket there. But even if you're a dedicated astronomer, you probably don't need to worry about that. But I find it interesting. When I learned that things actually do change, I was quite shocked. I thought that, the way we see things is the way they always are, at least when it comes to like our distance from the sun and the shape of the orbit and everything. It turns out, no, everything changes. It just takes a long time. Hopefully.
Also, your Twitter is hilarious. You're at that astronomer. And
I am?
yeah. So if anybody wants to just get some giggles.
Oh, well, thank you very much. Yeah, I'm kind of a smartass on Twitter. If Twitter is still around by the end of this talk, a sad but sadly true kind of a joke. I will, and I get people yelling at me all the time because they expect it to all be astronomy, and it's actually, except for when I'm plugging stuff that I've written, it's rarely astronomy. It's mostly terrible jokes, talking about Stargate and Star Trek, and ranting about politics. So if you don't want to hear me rant about politics, you probably don't want to follow that. But if you like really, I was going to say bad puns, but my puns are not bad. My puns are, mwah. And thank you very much. I really appreciate that. There's somebody way in the back.
Yeah. So what is your favorite thing to look at in the night sky, which is like a regular telescope that's visible in North America?
Oh, wow, that's a good question. There's an easy answer, and that's Saturn. Saturn is always amazing, and a lot of people don't know that you can, even through a small telescope, you can see Saturn's rings. And the bigger telescope you get, kinda, the sharper, the better they look. And if you ask astronomers and astronauts, typically, what got you into this? When did you what happened? And most of them will say, it's the first time I saw the moon through a telescope, or the first time I saw Saturn. For me, it was Saturn. And for a lot of my friends, it's Saturn, but sometimes the moon. And it's just incredible. And I used to live in the suburbs of DC. At Halloween, I would take my telescope out, and kids would come up, and I would say, you have to look through the telescope first before you can get a piece of candy. If they were able to. And it's October 31st every year, but there are different things up in the sky, so sometimes we'd look at the moon, sometimes Jupiter. But there was a year when Saturn was just perfect. It was low, right as the sun set, and so the telescope eyepiece was at a decent height where kids could look into it. And just kid after kid would look into it, and they couldn't believe. They would look in the eyepiece, and then they would look like down the telescope, or they'd look at me like they thought I was holding a picture of Saturn up in front of the telescope. It is that amazing to see it through a telescope. So if you ever get a chance to see it, it's up now. Absolutely take it. Jupiter, Saturn, the moon. Much more rarely, there have been some pretty good comets that have passed by the Earth in the past few years. If you saw Neowise a couple of years ago, it was a naked eye comet after sunset. And I mean, you could go out after sunset and go, there's a comet. And through the telescope, actually, the telescope magnified the image so much that it actually wasn't great through a telescope. It was best through binoculars. And so that was amazing. And I've seen 3 supernovae, 3 exploding stars in different galaxies through telescopes. And those are just dots. And one of them was so faint that it was right at the edge of visibility. Like, it was so faint that you'd have to stare in the eyepiece for a few seconds, and the atmosphere would blur the picture out, and you couldn't see it. And then suddenly the atmosphere would clear up, and then bing, there'd be this little point of light, and then bing, it was gone again. And a lot of people would be disappointed by that. But for me, my heart just swelled when I saw this, because I studied exploding stars. That's how I got my PhD. And to actually... To have a Hubble picture of one on your computer and everything is super cool. But to see one with your own eyeballs and think, yeah, the photons hitting my eye came from an exploding star 20 million light years away or something like that, that'll wreck you. That's cool. And so like I said, there's sort of a pedantic Saturn, because Saturn's amazing, but basically anything through the eyepiece. I love globular clusters. They're like my favorite class of object because they're beautiful. They're these clusters of about 1 million stars, and they look like bees flying around a hive. And the Hubble pictures of those are phenomenal, but again, seeing with your own eyes, that is really something. Everything is cool through a telescope. Astronomy is the best. And I don't say that because I'm an astronomer,
Star party
but it's true. There you go. Yeah, if it's clear. And how big is that scope? Oh, everybody brings. Oh, yeah. You want to do this. Oh, nice. Okay, yeah. So big enough to see the moon really well, and Saturn's rings and Jupiter's moons, and yeah, that's really cool. I have a small telescope at home too, and it's lightweight, so it gets used. And I have a bigger telescope that's very heavy, and it's a pain. And so yeah, people ask me too. What's the best telescope? And I say, First of all, that's like asking somebody, what kind of car should I buy? It's like, I don't know you. What do you need a car for? And it's like the same thing with the telescope. But the short answer is the best telescope to buy is the telescope you're going to use. And so, yeah, that's always my advice.
And every branch of solar has a telescope or more for you to check out.
Oh, that's really cool. Wow, very neat.
Any other questions?
Now I got to make a little eclipse here so I can see you. Oh, you do? Yes.
Okay, so this is kind of a stupid one, but why is it that planets are named after the Roman counterparts of the Greek gods?
Because the Romans were jerks. My wife's the historian, and she tells me this all the time. That basically the Greeks and areas around the Mediterranean and northern Africa were the ones who were basically figuring all this stuff out, and then the Romans came in and said, "This is all ours now," and it's almost that simple, and that's why a lot of the things are named that way. The planet that's not named after Roman gods is Uranus, which everybody mispronounces as Uranus, and everybody laughs about. And then I say, no, actually, it's Greek, and it's closer to Uranus, but Uranus isn't any better. If you think about it, it sounds like an adjective now, and it's like, oh, it smells Uranus in here. And if you want to pronounce it the way it should be in Greek, it would be Uranus. But nobody's going to do that. And in fact, if you think about it, if you know the stars, the star names like Aldebaran, Antares, well, Antares is a bad example, but a lot of the star names, Deneb, Rigel, these are all Arabic names, because the Arabs in that region were the first ones to really map the sky and do it really well and carefully. And those names are the ones that we still use. But for some reason, maybe the Romans didn't care about the names of the stars enough, I don't know. But yeah, that's why the planets are named after the Roman gods. Yes?
So in my neighborhood in the city, it's kind of hard to see the stars at night because of the light pollution.
Yes.
It's a big city, but there's still a lot of light pollution. I mean, have you noticed that increasing over the last years, or do you have any suggestions on, short of just driving out to the middle of nowhere, how to try to see the stars, in those areas?
Do you have a BB gun? Yeah, so I don't want to make any stereotypical Arkansas joke. Everybody has a .22 rifle at their house. Criminy sake, I live in Colorado. My heavens, they issue you a gun and a horse when you move there. So I don't suggest illegal civil disobedience, I suppose I would call it. I haven't noticed it getting worse, but only because I've moved several times. Now, I grew up in the suburbs of D.C., and it was not great. And even when I moved out to Colorado, I lived outside of Boulder, and Boulder was bad, but if I looked in a different direction, the sky was actually not so bad. Some places are getting worse, like Las Vegas is growing. I mean, Las Vegas is a horrible blemish of light in the middle of the desert anyway, but it's growing so rapidly that you used to be able to get away from it. Now you can't, and that's true. I mean, look at Lick Observatory or Palomar Observatory. These are built outside of San Diego and Los Angeles, and it's like, yeah, let's build a telescope outside of Los Angeles. Well, at the time it made sense. Los Angeles was a little town. Now, it's much harder to observe there. So it just depends on where you are. And some places enact dark sky laws. Tucson was one of the first places to do this because Kitt Peak Observatory is there. This is a world-class series of telescopes up there. And Tucson made it a law that you have to have shielded lights. Most street lights are just these big lamps. And so some of that light goes down, which is great to light up the ground around you, but a lot of that light's thrown up into the sky, and the sky glows and you can't see the stars. And so Tucson says, yeah, you have to have these lower wattage lights, they have to be shielded a certain way, and that's the law. If you build a house there, it's got to be that way. And the thing is, and people complain about it, oh, I don't want you telling me what to do. And it's like, yes, what we're telling you to do is to buy more efficient lighting that does its job better and will cost you less in the long run because you're using less electricity. So we're actually telling you, do this good thing. Oh, and by the way, you can see the sky, which is this magnificent artwork for free, and people still complain because people are funny. So I like to see more of that, and there are dark sky preserves that are becoming more popular. I hear about more and more of them all the time. There's one that's in Texas that, and we're talking Texas here, that actually is partly in Mexico as well. So this is an international agreement to make a huge, 50,000 acres, I don't remember how big it is, but it's immense, where the lighting has to be that way and everything is. So if you want to see dark skies, you gotta go.
We actually have the International Dark Sky Park in Arkansas.
Oh, do you? Okay, excellent. Okay. Yeah, the International Dark Sky Association is a good group of people who have basically they have guidance. They have things you can buy, and you can actually, if you want to be active civilly in your town, and you can actually download these things and say and present them to your city council or whatever, and say, yeah, look, these are guidelines to make this better, and this is better for everybody. It's an expense now, but 10 years from now it'll have paid itself off. So there are all these great things to do. And where I live, I still live near, I'm in rural Colorado, but there's still a bunch of towns near me, Fort Collins and Boulder and Longmont, and my sky is miserable where I am. I can see the Milky Way barely. But if I drive into the mountains, go like 3-4 hours to the west, yeah, if you've never been to a dark site, you cannot understand what this is like. There are so many stars, it's hard to identify them, and the Milky Way is just this raging storm across the sky. It's gorgeous. My wife, again, astronomy adjacent and sick of all my stories. As you can tell, I make any short story very long. We went out, the first time when we were doing our science vacation company, we went out to rural Colorado to look for some places, and she had not been to a site that dark, and we walked outside, and she was like, oh my God. I was like, yeah, this stuff is really cool. So thank you for asking. That's a great question. These have all been really good questions. Are there any more? Okay. Going once, going twice.
You got the lobby, and you have folks already for the slide. We'll do that, which is why the depth of the stars up here at the box.
Well, thank you all for coming, and again, thanks to the Arkansas Space Grant Consortium for bringing me out here. This has been terrific. I actually like this weather. It doesn't rain where I am, so for me this is like a really cool event. And I really, really appreciate you all coming out in this weather to hear me talk about this, and I hope you get to see the eclipse in 2024. Thank you. Oh, I'll bring this out with me. It'll be sitting on the table out there. This is